A child aims their slingshot at a fruit. As the rock leaves the slingshot, the fruit drops due to the wind. Will the rock hit the fruit? Provide your answer with proof. So what we're looking at is a ground, and we have an object at a particular distance away and at a particular height. So we say the kid is aiming from here, the kids are aiming from here, and the fruit is over here. We'll consider that. So let me just take a second. Yeah. So basically we are here, as the kid is over there and the fruit is over here. So we can call this as H, we can call this as R. Right, and let me make it very clear. This length is H and this length is R. So that's that. Now, this length, okay, let me not do it over there. This is how the kid is aiming. So this will be a launch of the rock. So we'll call this angle, let's call this angle as theta. Let's call this as V naught. And let this be 0, 0. This will be R, H. And we have the diagram. Okay, so this is a situation. We have a bunch of kids trying to get this fruit down. But apparently when one of them tries to do it, what happens is, obviously it goes in projectile motion in this manner. But at the same time, the fruit also started falling when the stone started traveling. Right? When the slingshot ended pushing it, the fruit also started to fall at the same time. We have to check if the fruit and the rock, right? If this is the rock, and say we have a fruit, will they hit is the question. What do you guys think? So yeah, I mean, they do hit. So I'll tell it's an S, they do hit. But how will we prove it? Or I'll ask you guys this way. I'll give you guys, this is the clue basically. What will connect the falling fruit and the rock? What mathematical or physics quantity connects these two aspects? That's your key. Think about it. What connects? What can it be? It is time. Okay, guys. See here. Aims for the fruit. As the rock leaves the slingshot, the fruit drops due to the wind as the log reaves. So basically, what is this talking about? Same time. Both of this thing are happening at the same time. So the time it travels to this point, if the fruit is able to reach that point, they will hit each other and you have your hit basically. The fruit apparently will hit the rock. Okay, that's the funda. So how do you find out the time and all of that? Well, the rock has to travel a distance of r. That's your clue. Okay, so I think I given enough clue for you guys to start off with. So I'll start off by looking at the stone. And what should I do? I hope you guys have tried. Yes, we need to take x component. All the things related to x component. So you have the initial velocity to be v naught cos theta. Then we have the distance. That will be x naught is 0 and it's going to travel a distance of r. And then what else can we tell? Time over here is say th, or let me call it as some point over here. So let's consider this as R comma B. So this is at a height of B. So time taken by the rock to travel the horizontal distance of R. Okay, so that, oh yeah, sorry, that we can call it as TB, I guess. Okay, let us call it as TB, not an issue. So what is our expression? So we are trying to get an expression for time, TB, in terms of all of this. So let's make use of x is equal to x naught plus ut plus half a t square. So this is r, this is 0, this is v naught cos theta into tb, then minus g by 2 tb square. Oh, sorry, there's no acceleration due to gravity over here, my bad. This is 0 plus 0. So our tb will be the time that the rock travels this distance will be r by v naught cos theta, right guys? So see, the funda is quite simple. If I'm able to reach this in 5 seconds, right, then I'll be able to also talk about how much time will the rock take to reach this height. And during the same time, if the apple or the fruit is able to reach the same height, then we have the answer. That's it. At the same time, if both are reaching, means what? They'll hit each other. That's what we're trying to figure out. So we're trying to get an expression for time, which we got, and trying to relate all of them. That's all we're trying to do. So all I'm doing is I'm trying to see what time the object will reach this point basically. That's all I'm trying to do. And in the end, we'll see, yeah, how much, where the object is, where the apple is basically. So all I'm trying to do now is get an expression for, or figure out where the object is in terms of height for this time period basically. Okay. So for that, what should I do next? I should consider our y component. So we have u of y, which is equal to v naught sine theta. Then we have acceleration is equal to minus g. Then we have y naught, initially it's at 0, and y is equal to b basically. I'm calling it as b. Okay. So b is the height it reaches. B is the height it reaches at time is equal to TB. Okay, guys. So that's my assumption. That's my call. Right? So let's get an expression for B. Let's have a go. So y is equal to y naught plus v naught sine theta into TB minus half g into TB square. So let's keep this. Let's not substitute all of this. It might or might not cancel a few things, but let it be. So that's our expression for B. Now let's figure out A is the fruit. So we are trying to figure out the position of the fruit at t is equal to TB. Okay. So basically all we have to do is, it's not changing along the x-axis. All we have to do is only the y component. So along the y component. So what do we have? We have, it starts off with a initial velocity of 0 meter per second. It starts off at rest. Acceleration due to gravity is minus g. Then what else? Then initially it's at a height of h. That's one thing. Then anything else? That's it. So y will be equal to h plus 0 minus half into g into tb square, right? So you can compare this to y and this expression. So we can see that if I ignore the zeros, right? If I ignore the zeros, what do I end up with? I have h minus half g tb square. I have v naught sine theta tb minus half g tb square. So this expression and this expression are the same. Good, I didn't solve anything. That's the point. You can't just solve for the sake of it. So these two are equal. So all I have to prove is v naught sine theta into tb is equal to h. Okay. So let's consider v naught sine theta tb, and actually I should be writing it over there, not over here. V naught sine square tb, and now I'm going to substitute tb from 1. tb from 1 is over here, r by v naught cos theta. So v naught sine theta divided by r by v naught cos theta. So v naught get cancelled. So sine by cos is sine theta by cos theta is, I should tell theta, if not it's wrong, into r. And what is tan theta into r, guys? Let's go back to the diagram. R is over here, tan theta is opposite by adjacent, h by r. So let's write h by r. So this is h by r into r. So this and this will get cancelled, and this is equal to h. So we finally proved it. So I'll call this as, say, A. I'll call this as B and C. From A, B, C, what can you tell? Finally, from A, B, C, B is equal to Y. Okay, so both are equal to h minus half g tb square. This implies both the rock and stone, sorry, not stone, both stone and the fruit reach the same coordinate at the same time. Thus, the stone or the rock will hit the blah 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 blah. Yeah, you're not in 6th grade. You guys can conclude. So basically I just did that, See, all I did was, even I didn't know how to approach. At the start, I was like, how do we go about doing this? Then I thought about, okay, let's just forget about everything. Just let me put the diagram. I drew the diagram. And then I started thinking about, let's see where will the rock reach over here. Then I was thinking, how will I know how to fix the coordinate? Then I went back to the horizontal component. We know horizontal component has this stable thing that it will always move in constant velocity and so on and so forth. So I went on to just write this expression. I got TB. Then I was like, okay, I'm able to travel this distance with this particular time period. I want to see at what height will this object be, the rock be, and at the same time, what height this fruit will be. I just went on with that instinct and I got the answer. Literally, guys, me coming up with this time after reading the question was not instantaneous. I just wrote the diagram. So what I'm trying to tell is, sitting and just looking at it will not fetch you the answer. Whenever you get any difficult question, just write the obvious. Just start off. Just write the obvious. Just write, step whatever you can on the screen or on your paper and all of that. Do a rough work. And once you get a rough work, then you can approach the answer. It'll just take a diagram and few writing space, and you will get how to go about. You'll get the factor basically. I got time as a factor as and when I wrote this expression. I got time as the factor and I went on to solve the entire answer. That's it. So that's my basic thinking. And this is how you have to solve any complicated question. Okay, you can pause and have a look.